Hello dear friends and welcome to our popular IoT webinar. My name is Alan, I'm HARDWARIO CEO.
And hello, my name is Pavel and I'm CTO of HARDWARIO. And today we will be talking about a very interesting topic, which is LPWAN technology.
LPWAN, LP, low power wide area networks. So let's start, Pavel, with the history, because HARDWARIO was established just because of these technologies, right?
Yes, so we had some experience with radio technology in general. And back in 2016, the LPWAN and especially LoRaWAN was on the rise. And we felt that this will be a disrupting technology for many, many applications.
And it is.
It is.
It is.
So, we started like in 2017, we were adapting already and designing LoRaWAN devices. And back then we also started talking to Vodafone, which offered narrowband IoT as the first company in the Czech Republic, and is the strongest narrowband IoT player in Europe in general. So later we developed a product called Chester, which can utilize both, but we will talk about this later.
So we'll talk about Chester, in many ways today. Basic division of these LPWANs. I mentioned LP stands for low power and WA for wide area.
Wide area networks.
But there are other telecommunication technologies we are using to connect device or the thing to the internet, because we are talking about Internet of Things. Mm-hmm. So let's start with this.
So generally speaking, there are multiple ways how you can do that. You can take a device, if it is equipped with Ethernet port, you can use a router and be connected, but that's not very low power option. Also, you can have Wi-Fi, which is definitely great, but there is a problem that you have a vast diversity of routers and in infrastructure devices. So for serious industrial deployments, that's kind of overhead on supporting your deployments. And also Wi-Fi, despite it is generally available, it has some issues related to physical limitations. Mm-hmm. Like 2.4 gigahertz is fairly high frequency. It is difficult to get through the walls, and you will have a lot of problems with interferences from other networks and different protocols which are operating in the same bands. Mm-hmm. So you can also be using other types of technologies like Bluetooth with some phone as a gateway and stuff like that. So there are really lots of options how to connect a physical device to the internet. But in this talk, we will be talking about devices which are not either dependable on any sort of local infrastructure, or they depend on infrastructure that is built for rock solid and long-term usage with low power features. Mm-hmm. So the low power wide area networks, it's offering low power consumption, and it offers great communication distance. And that's because these protocols are operating on mostly sub-gigahertz frequencies, and therefore the signal penetration is much better than with higher frequencies. And also they are using narrow channel bandwidth. What it means is that if you have wide bandwidth, like you have with Wi-Fi, you are of course able to stream data on a high data rate. This is why you need wide channel. But with industrial devices, usually you don't need that. You need to transmit a couple of bytes or hundreds of bytes. But more important is the reliability and communication distance. So what you do is if you narrow down this channel bandwidth, mm-hmm. you get less noise on the receiver side, and therefore you are getting better signals to noise ratio, and you are able to enhance the sensitivity on the receiver side. And also it's related to the spectral density. So when you concentrate the transmission power to a more narrow channel, you are able to achieve higher spectral density and communicate through a greater communication range. Okay, so that's the basic physical idea why why you are not following these, wideband and high-speed protocols, and why you can get multiples of communication range with the same transmitted output power.
Okay, so quick summary. We have some near-field communication technologies like Bluetooth, and we are using Bluetooth, to configure.
Yes,
our
it is
devices,
definitely you cannot say that some protocol is better or worse. Yeah. Everything has its place. That's important.
So this is one. You mentioned Wi-Fi. Of course, if you want to watch a Netflix movie and you want to connect your TV, it's a perfect technology, right? And we have 2G, which is dying, and 3G.
It is getting obsolete, and it's just a matter of time before it will be switched off.
Still, we have a 4G and 5G, which is, right now growing. And then we have this low-power wide area networks. Long range, this is one, advantage of this technology. Low power, so we can operate our devices from battery for years. We are talking about years, like 5 up to 10 years. I heard even 20 years, but...
Well, we make big battery packs, so I can imagine it's possible.
And the third part of this, and it's because it's not that complex technology, it's a low price, affordable price. That's, why it's so perfect to use this technology in these industrial IoT projects.
Yeah, you are right. It has to be attractive.
And I read this report from Ericsson about development of massive IoT technologies like these LPWANs. And really we are talking about billions of devices. Just last year, this narrowband IoT and LTM reached 300 million connected devices. And it will grow up to...
It's an impressive number.
So it's an impressive number. And we know because we are talking with our partners, and we are talking in tens of thousands or thousands of devices. But still, it's a great technology, to be developed. So great. We focus on LPWAN right now, and let's mention the most popular technologies inside of this group. And let's start with LoRaWAN.
Yes, so LoRaWAN has been here actually for way longer than most people think, because we have to speak about modulation itself, the LoRa modulation, which is held by Semtech company. The principle of this modulation has been actually invented in Second World War for communication between submarines, but on much lower frequencies. But the principle has been taken to this sub-gigahertz level, which is a great idea. And the modulation itself, with the same transmitted power, already offers and comes with much or multiples of communication distance what you would have achieved on traditional modulations like frequency shift keying. So LoRa itself is a modulation. Remember that. And there is the other thing, which is the type of network and protocol, which is LoRaWAN. So don't really mix two things, because you can have LoRa radio and still doesn't have to be LoRaWAN technology. But LoRaWAN is like the whole ecosystem. And in this ecosystem, you have LoRaWAN devices, like we have Chester or Sticker, Tower, and others. You have LoRaWAN gateways, which are essentially pass-through devices which are listening to your air radio traffic and passing this through UDP channel over LTE or over Ethernet. It can be some other conventional channel. And they are sent to LoRaWAN server, which kind of orchestrates the whole network. So you can have multiple gateways installed across multiple factories in your company, and they talk to some central point which decides, okay, I have received the message from device 1 through a gateway ABC, but because gateway C has the biggest signal strength, I will use this gateway as a back channel to reply to the device that the message has been, for example, received, or I have something to send back. So LoRaWAN operates typically in 868 MHz in Europe, 915 in the United States. There are 3 classes of LoRaWAN devices, ABC, Class A means that the device is mostly sleeping and sometimes transmits the message and goes back to sleep. Class C is that the device is always receiving. Of course, it can also send a message, but you can schedule back channel transmission to the device at any time through the gateways. And Class B is something in between. So it's also a sleeping device, but it wakes up in regular intervals, starts the receiver, and it is synchronized to the network, and the gateway knows when to send the message to the device. So you can kind of make this low power receiver. Of course, it has a little bit increased power consumption, but that's just for the clarification what these classes of devices stand for. Speaking of the payload, you can transmit, well, to be vault-wide safe, you have only 11 bytes. But of course, you can always scatter the message across multiple transmissions. You can also use ports to differentiate the type of the message. But in Europe, it is safe to say that you have like 51 bytes. And also depends on the so-called spreading factor. I will not go into details, but LoRa is kind of dynamic system. It can negotiate what is the modulation range, modulation rate, and based on that, it will shorten or prolong the duration of the transmission, so you can conserve some power. And this is related to this maximum payload in some regions, because on the very high spreading factor, the longest on-air time, you cannot utilize like 50 bytes of payload. You have to make it shorter just to fit the regulations. You have to remember it's still license-free band, so you have to comply in Europe. You have to comply with the rule that the device cannot transmit more than 1% in an hour, so which is like 36 seconds. So this is why you have these limitations of number of bytes transmitted. This is why I always say LoRa is a great technology if you want to build your own network, if you cannot afford to really send the data maybe to the internet, or simply you want to have lots of local devices, and going with cellular IoT, we'll talk later, maybe doesn't really make sense economically. It could have, but you have to really make the math and calculate where is the break point. But of course, if you have some requirements on your application that you want to transmit higher amount of data, and you want to deploy the devices around and in multiple countries, then you may be started worrying whether other technology is not more suitable, because yes, with LoRaWAN you have providers. You have providers like the Things Network, it's the community net provider. You have in Czech Republic, you have ČR, and they have quite solid coverage in the cities. But if you really want to go like country-wide deployment, you probably want to look at cellular LPWAN.
Okay, definitely it's a great technology, and one of the reasons why HARDWARIO exists. And what we can do for our viewers. Maybe there are some people who are not that familiar with this technology, and they're asking, okay, so it sounds very complex. What HARDWARIO can do for them? So let's start with this, that in most cases we are using LoRaWAN the way that we are building local network for our partners, like we did with Skoda Auto, or with other clients. So this is one approach we are building, and what we got in our hands. You mentioned Chester and Sticker and Tower devices. This is a perfect device. This is something we called
LoRa Tester.
LoRa Tester. It's built on our IoT kit, and it's very, very popular. And I saw many pictures how people are using it and how they are mapping, the coverage of their LoRa network. So speaking about devices, we are covered, but we have one more product we are recently put in our portfolio. It's called Ember.
Yeah.
Can you briefly
Yep.
describe this?
So Ember is LoRaWAN IoT hotspot. The idea is that you have basically a router. On one end, you have traditional connectivity like Ethernet or LTE. We usually supply it with LTE card and even a global SIM card from Twilio pre-installed. and we have LoRaWAN card installed inside this Ember product. So you connect a LoRaWAN antenna, and all the traffic is passed to your LoRaWAN server. It is up to you really how you will get with this LoRaWAN server. We have a service called Ember Cloud and Ember Connect for the connectivity. And through these services, it is like worry-free. You just plug it somewhere in the socket. You have Ember in rugged IP67 enclosure. We even customize it. We print custom logos for our partners. And it's plug and play. You plug it somewhere, and you can use any LoRa devices and use our Ember gateway as a pass-through device. The Ember is based on MikroTik technology, which many of you are well aware that it's a recognized brand in router business. And some years ago, MikroTik started investing into this LoRa technology, and we have adopted this. And Ember is like this integration product, so it's a connection of hardware, mechanical integration, enclosure, and all these services and configurations around that.
And this is very important, because one thing is that you can buy devices, LoRa devices, in many marketplaces. That's fine, and we will be happy if you will use our devices. But we can supply with this Ember, we call it IoT hotspot, and these services, even this server, you can have in the cloud. But what is the most important, we give support our partners. So we teach them how to use it, how to install it, how to provide services, and this is very important. Speaking about some real projects which are based on LoRaWAN technology, I have to mention most recently a nice project with our partner Yotor, and project in the United States for William Warren self-storage company. So we are building these IoT hotspots based on LoRaWAN. We are connecting stickers and Chesters and even other devices to this LoRaWAN, and it's based on this hardware Ember and Ember Connect and Ember Cloud service,
exactly,
which is great. Another nice project with our partner Sur in Australia. We are using LoRa to transmit data from
energy meters.
Energy meters, nice. Of course, Skoda Auto, when we built our LoRaWAN network, like a local one, and we are using. And we can talk about more and more projects, but it's almost the same. Give us your idea. We will help you to build this LoRaWAN network, local network, and we will give you support. Okay, Pavel, let's close this LoRaWAN topic and move to another beautiful LPWAN technologies like narrowband IoT and LTM.
So these LPWAN technologies, NB, IoT, and LTM, fall in what you call cellular IoT. And that means that they are provided by carriers, and usually they are featuring nationwide coverage. This is why they are so attractive today. We also talk about some other benefits and attributes. But first, let's maybe ask, okay, if these both technologies are offered by carriers, for which should I go? So usually the answer is it depends first on the application and on the availability. There are countries around which offer both. In Europe, most countries today offer only narrowband IoT, but we have come across countries which offer only LTE-M in North America, Canada. But the good news is that with Chester, you are covered for both. We have the technology that can smoothly switch over one to the other. And back to the question, which one is better in terms of properties? I usually answer that if you have mobile application that is traveling around, it can be some GPS tracker. For the future, when let's assume that LTE-M is available everywhere, I think that's the way to go, because there is a seamless roaming handover capability, like in traditional LTE, and there will be easier to achieve the point where roaming agreement will be set between the carriers. This is what already the virtual mobile operators are offering today, these VMOs. They are offering a global LTE-M SIM card, and whoever is offering LTM connectivity, they can have this agreement with, and you can have one SIM card to roam freely between these regions that are part of the contract, which is not the case with NB-IoT. However, narrowband IoT has other advantages. It has a better signal penetration in deep indoor and far field places. So if you have stationary application, like in factories, you are monitoring machines, which is sometimes in a fairly noisy environment, and we have come across these places, right? That there were little bars even for standard LTE reception, but our NB-IoT devices are performing very well in such conditions. So I usually for these stationary devices recommend narrowband IoT. You will get better. Also, you will get a little bit better power consumption, but it's not always. Sometimes there is a trade-off. Yeah? If you are transmitting more data, you can get even better in power consumption with LTE-M because they are using a little bit wider channel bandwidth, and they can do the transmission much faster than NB-IoT. So again, that depends on the application use case. But narrowband IoT performed, and Nordic has made a test comparing LTE-M and NB-IoT in the nature in some mountains, and it was obvious that NB-IoT is performing better on radio level.
But the truth is that right now we have majority of our projects are running on narrowband IoT.
Exactly.
But we can see that more and more countries are developing the LTE-M. So, and LTE-M is a real replacement of 2G, of GPRS, definitely.
Yes, so what we have seen in the countries where they have already switched off 2G and GPRS and Edge and all these legacy technologies, that they always somehow had LTE-M ready. So I'm not saying that it's some kind of rule, but it's like natural transmission. Because with if you have some GPRS-based application, with LTE-M, you can always get better in all aspects. So you get better power consumption, you get better coverage, and you get better latency and all stuff. So it's like a replacement. Whereas with NB-IoT, you cannot really say that it will outperform GPRS in every aspect in this, but with LTE-M, yes. So we think that LTE-M will be there for the future, hopefully in every country around the world. But NB-IoT will definitely have its place for industrial devices. And we see it in China and Asia. They are deploying lots of NB-IoT devices because actually this is where the protocol even originates from. But we are also seeing this growing trend in Europe and North America as well.
Yeah. So just few technical aspects or parameters of this technology. You mentioned the data volume. We know that we can transfer up to 10 megabytes of data when we are speaking about narrowband IoT.
Exactly.
With LTE-M, it's like a much more like
it's like sometimes they make tariffs for 50 or 100 megabytes. Yeah. And even with NB-IoT, theoretically, you could even transmit more, but it's not so common by carriers because it's still intended for these low power devices, and if you are transmitting more, maybe the technology is not the right fit. On the other hand, 10 megabytes, trust me, it's a lot of data. We usually don't have applications exceeding that limit.
But we can say that for LTE-M, you know, it's something which is better as a parameter. You can send or you can transfer more data. Speaking about consumption.
So NB-IoT can perform better on smaller data chunks.
Coverage.
Definitely NB-IoT leads here. And
something else, it's a the
latency is much better for LTE-M, way better. So for some applications like trackers, real-time trackers, LTE-M really is better approach. But, and of course, this mobility, roaming. I think roaming, it comes in many cases. It comes to business decision. If somebody wants to have.
But good news for our partners and customers is that, you know, like always, you know, we are talking about your projects. You know, we are trying, you know, to find the best technology for you, and maybe it will be LoRaWAN, maybe it will narrowband IoT or LTE-M. We have one device which covers all three technologies.
Yep.
So you can rely on us. Great. So let's talk about the latest projects we have with narrowband IoT. Let's mention some not the best one like that, because we all projects, but the famous one, for example, with Asahi.
Yeah, so for digital retail, we are doing this real-time monitoring and getting metrics about customer behavior, how they are taking and getting the goods and prioritizing.
And obstacles were very obvious. There was no power supply from the main, so there was a need, to operate these devices from battery for years. So it was one challenge.
Yes, absolutely low maintenance, and no need for agreements, local agreements with the retail stores.
And it was the same with the connectivity. So we knew that we will deploy this project with Narrowband IoT, but we were very surprised that even in deep indoor places, we're able to connect. Because when we are talking about pallet, and antenna, which is installed somewhere down there, close to
under gallons of water.
Yeah. And still, we are able to send data. It was a fantastic experience, right?
Exactly.
So this was very nice. The same with Lego, because we are doing almost the same with Lego. We monitor demo boxes all over the world. Most of them are in the United States, but it was the same story.
Yeah, we are just gathering the data and how people are interacting with these demo boxes and how much time they spend with it. So they can see which one is more popular than the other and prioritize the strategy.
Another nice projects we have with in factories. We're monitoring TACT or overall equipment efficiency or effectiveness in these factories. So we connect some big machines, and of course there is a lot of energy, but sometimes it's really hard, to connect this device to electricity grid. But what is more important, installation is inside of these cabinets, sometimes metal cabinets, and we are still able to transfer data even from these metal cabinets, which is
driving me crazy.
It's a miracle, and
placement.
And people are staring at us like, hey, and to build infrastructure to just send data from this machine, wired infrastructure, it's costly, it's time consuming. And we were done in several hours. The whole installation was done in several hours. It was great. And with LTM, we have nice project with University of British Columbia right now in Canada.
We figured out that there is no NB-IoT provider, so we started cooperation with Roger Wireless, which is the carrier which provides nationwide LTE-M, and it works. The nice thing is that this university leads the development of their embedded application for Chester on their own, and soon they are deploying this forest monitoring project with the connected weather station. So, Alan, you have mentioned that Chester will get you covered, which is true, LoRaWAN, NB-IoT, LTE-M, but there is one more very appealing communication interface or radio technology for people and projects where it's not possible to even achieve these narrowband IoT or LTE-M networks, because
definitely we have our partners, watching us from Latin America, from Brazil.
So
and from other countries.
Greetings, Australian partners, Canopy Tools and others.
Yeah, and even in Africa, we have
so
some projects.
We still have to remember there are big countries, and we as a Hardwario, we want to cover all the world, right?
Yeah.
So we are left with the option going satellite, and this is a big and hot topic these days, because there have been companies who invested into this technology and felt this opportunity that LPWAN can actually go to low Earth orbit, and we could communicate directly to space. And today it's, I would say, in early phase, and I'm excited that there will be some groundbreaking moments for these companies when they are deploying more and more satellites. But already today you can get into it, and there are a few players which are vibrant, and you can search them. and they are able to offer you with the dev kit. And we have been testing
and
these
we did
technologies.
it. Yeah, we already sent.
We have been, and we talked about it like 1 or 2 years ago that we were evaluating this technology from French company Kinase, and it was the first moment when we calculated the path of the satellite, and from the window of our office we were able to transmit data through it. They are definitely going further, and they will be deploying more and more satellites. I spoke to them recently, so they have some plan. But there are some applications where it would be still difficult for today's deployment. For us, for example, we had this project in Australia, and we were searching for somebody who has the possibility to synchronize, and you don't have to calculate the passes or download the data about these passes from external channel. And there is a company called Astrocast, which has solved that problem with synchronization, and it seems like for us they will be a nice go-to partner for immediate deployment, because that is actually the real solution that we can put in our Chester device as a cover module and offer this extension board for the satellite connectivity. Extremely useful for telemetric applications, for agricultural field, because you don't need a guaranteed latency of seconds or even minutes. You just need to measure some sensor or soil sensor or some ultrasonic ranger about the water level and stuff like that, and be able to get and gather data at least once a day or several times a day. And Astrocast can guarantee in the absolutely worst conditions that when you send the message to their module, it will arrive in Azure IoT Hub no later than in 6 hours. But that's the worst case, yeah. They can do it even in minutes, and they are planning to launch more satellites, and they want to get, in the worst case, to guarantees of 15 minutes. So which is fantastic, and in some cases it will be even suitable for notification systems. So satellite will be option that will be available to our partners as extension in a foreseeable time. So definitely stay tuned about this.
Yeah, it will be some special module.
It will be sitting in the cover module. There will be this special antenna, and through the system connector, it will be connected. And in our Chester SDK, there will be full support, and it will be a matter of, again, few lines of code to transmit data to satellites and receive it to HARDWARIO Cloud, which we will talk later.
And what is the difference between, because there are some satellites technologies today, they are not low power and they are very, very expensive. So of course, for some use cases, when you need to call, and to make a call, from some place, you will pay for it. But speaking about our business, our IoT business, which has to be cost effective, we are talking about $1 per month or something like this. And this is exactly what they offer. Even for 1 kilobyte per month, but they offer for $1. So our goal is, or our task, our job is, to do it the way that we will do some edge computing, and we will send just this 1 kilobyte
results.
Or several kilobytes per month, and the price will be just several dollars per month. This is the difference. And of course, this low power mode. So Kinase, we did already. And we are still in touch with these guys, and we are waiting for more and more satellites. Recently, they were certified by Deutsche Telekom. So we can see that many big, huge companies, and even European Union and United States as a government investing into these technologies. Now you describe this Astrocast, which is a nice technology, and we are very close to them. And there is another one, and you spoke this to the guys recently.
Exactly, and another promising technology is narrowband IoT in the space. And there is a company called Sateliot, which is fairly new and investing into this trend. And basically what is happening is that now the final specification of narrowband IoT release 17, it's done, it's finished. And it accounts for this satellite communication, and I cannot tell the details, but there are actually module vendors which are already finalizing the chipsets for this, and Sateliot will be offering early adopter programs, packages to companies who want to integrate this technology. The initial launch should be sometimes mid next year. And I will not disclose pricing or something, but it is possible to already get in touch with these guys. Please let me know if you want to get connected. We have contact windows in there. And the difference in this NB-IoT will be the combination of terrestrial NB-IoT in places where it is available, because of course it makes sense to use the terrestrial network for enhanced transmission efficiency. But if it's not there, it will be possible to use the satellites. And the beauty is that you will have one single module that will be able to handle both scenarios. So yeah, we haven't evaluated. It's still in the future, but not that far away.
Yep.
There are already agreements with SpaceX that they will launch their satellites. So we will see how it goes. We will definitely keep it in touch with them. So good luck, satellite guys, to work on your mission, and we want definitely to be close on this.
Exactly, you can see these opportunities: agriculture, forestry, maritime, all these places where sometimes it's really hard to transfer data. And our mission is to connect things to the internet, as many as we can from all around the world. So we need such a technology. Stay with us, dear friends. You can see these LPWAN technologies are just fantastic. Sometimes it can be very hard for some of our partners and customers to understand, how it works, what is needed, what technology you can use. But we have some good news for them.
Yeah, exactly. So we realized that investing in all of these technologies take tremendous investments and time for integration. So we want to cover this job and offer our partners with all the bells and whistles not to actually worry about it. We are providing hardware platforms which integrate those technologies, but also we provide for seamless integration the services and cloud solutions which are unifying the way how you access the data from all these different technologies in the same manner. So HARDWARIO Cloud is exactly taking that role, and it can ingest data from various sources like LoRaWAN, cellular IoT, and in the future even these satellite technologies. And it comes with REST API interface and the possibility to deliver the messages immediately to your endpoints upon configuration. And also it's not about this software foundation, it's about services. So we cover connectivity, we cover SLA and all the support around it. So you basically get this connectivity tunnel in one price package, and you don't have to worry about the way how the data is actually delivered. We handle this part.
And speaking about this connectivity, because of course you can sign a contract with each local carrier, like what we are doing, and it's again it's time-consuming process, and you have to you have to commit you have to do a huge commitment, to get good prices. But again, there are nice movement in this era.
So thank you for mentioning that, because yeah, either you can, for example, if you want to get professional NB-IoT connectivity, you can probably approach Vodafone and start negotiating, but it is some process. It takes several months. You get to the point that you will need enterprise level agreement, as we do have, and you will get some benefits for such type of agreement. You will get private APN, so you are isolated from all the public traffic, but also you will get the benefit that all your devices connected to the network have associated fixed local IP address, which is important if you want to do bidirectional communication, and we are preparing our technology to be able to leverage these features. You can then cache the messages for these particular IP addresses, and it will be delivered as soon as possible, or even immediately if the EDRX feature is supported there and Vodafone supports this enhanced discontinuous reception. So definitely this enterprise level agreement makes some sense. You have the other option, and to get prepaid NB-IoT card. but then it's available for everyone, but there are some limits. You can get like more than, I don't know, some hundreds of SIM cards
some hundreds
per company or per person. But on the other hand, it's quite nice offering. It's lowering the barrier. If you want to start with NB-IoT, you want to test the technology, you can now buy the package of SIM cards and you can start right away. It's fine.
Yes, you can use Chester with
exactly.
Open SDK. Many universities, if you are, student or PhD or professor on university, it's a nice combination, this one. But still, you can even use our SIM cards.
Yeah, and you will have these limitations, like you will not have fixed IP address, so you have to keep alive some socket if you want to do bidirectional communication. So it's not that easy. For example, with LTE-M, as we mentioned, it's a technology compatible for roaming agreements. There are players, these VMOs, these virtual mobile operators, which make this offering that you get a global SIM card, they usually call it. So you get one SIM card you can use across hundreds of carriers where they have made the agreement, and you have one SIM card management platform. So you have the overview about the power consumption, data consumption, and other stuff. Now there is like lots of opportunities where you can go with these SIM cards with companies like Sierra Wireless, or now we are talking to this Danish company, Onomondo, a little bit strange name, but they are making a really nice technological proposition, because they are saying if you get our global SIM card for LTE-M, you will also be, we have like the core under our control, and you will get your own private APN with the fixed IP addresses. But what we do is that your device communicates on a plain, simple UDP protocol to our core network, and we have created connectors to Azure IoT Hub and stuff like that. So you can keep safe communication, which is simple, and you don't need to add extra data overhead for the security reasons. But on the other side, you are getting the data feeds to these Azure IoT Hub or Amazon IoT Core and these services. So I would say they have changed the traditional way how you can deal with the data, and this is why we are very interested to deal with Onomondo company. Speaking of the LTE-M connectivity. Definitely.
But in the end, for our partners, it can be a simple task, to create the partnership with us. We'll provide hardware, this cloud, HARDWARIO cloud services, and everything will be included, even the service level agreement. Or, of course, you can do it by your own, and we will support you like always. Pavel, so it was really great, to talk about LPWAN again, because these technologies are, moving forward very fast, and I'm so happy that we are able to keep the pace with the world of these beautiful technologies.
Well, hopefully we are leading the edge, right?
We are leading the edge, and definitely every time. The next webinar will cover the whole infrastructure which is behind the Chester, like a Chester SDK, because we are preparing the open workshops with our Chester SDK. So it will be great, and we can describe how it works.
Yeah, definitely. Join the next webinar in this series, because it will be kind of like smooth continuation of this one, because we will be just showing the tip of the iceberg, how easy it is to use Chester open platform for our partners and Zephyr RTOS to actually build your own embedded applications connected to LPWAN, and it will be like a teaser for this whole day training, publicly available for everyone. I think that will be exciting. We will do it sometimes in summer. We will clarify the date, but I think that will be like a nice bridge to very technological and very interesting training.
But it will be in few months. But now let's go to Q&A session.
See you there.
Hello, dear friends, and welcome to Q&A session. And let's start with your questions, because we have many of them in a chat, and don't hesitate to put your questions there. So we will start with a question of Louis Riccardi. But I can see that this question is about battery lifetime, and I can see that there is another question of BFATE. So let's merge them and answer. So the question is, hi, quick question. What's the typical battery life for a HARDWARIO endpoint working in a narrowband IoT? And also, what's the best HARDWARIO device, endpoint device, that may work in LoRa and narrowband IoT? So this is the first question. They got two parts. And the second question is, how do you calculate the energy consumption of your LPWAN devices? And if it's possible to get a good prediction given the amount of data transmitted over, let's say, narrowband IoT. I will ask my colleagues if they can put into the chat the link to blog post about the batteries.
The article.
But now it's time, Pavel, to answer those basically three questions about what is the popular device.
So here we have to emphasize that the biggest efforts goes to our configurable gateway Chester, which has both LoRaWAN connectivity and cellular IoT like LTE-M and NB IoT. This should answer the first question. Of course, we have also other devices, Discover, Sticker, and other platforms. But this one is the most versatile because you have all these expansion interfaces. You have lots of flexibility in terms of power consumption and power sources and stuff like that. So Chester is usually the first go-to option if you are deciding on which platform you will build your next LoRaWAN or NB IoT project. So speaking of the battery lifetime, of course it depends. But when I take into account that Chester itself has some base power consumption of like 200 microamps or 150 when Bluetooth is enabled. So that's like the baseline. And then to this you have to add up the average of the transmission and of course data acquisition, the sensors and stuff like that. So if I say that 200 microamps is the baseline, so let's assume that Chester is not transmitting, the battery lifetime from our soft batteries can be, I guess it could be like 4 or 5 years maybe. But of course, if you add up the transmission, and I don't have real figures, so please take this with a grain of salt. But let's say that you will transmit every half an hour, and you are in good conditions. So that could be like 100 microamps. So you will lower by 1/3. And your power estimation or battery lifetime will be 2 years, for example, or 3 years. So we usually calculate the figures exactly when we develop the application. We use this power profiler kit from Nordic, and we observe the power consumption over a long time window, and we get the exact mean current. And based on that, you can divide the capacity of the battery by this mean current, and you get fairly good idea for how long the device will be operating in the field.
Okay, so there are other aspects like a quality of signal and this kind of things.
And this plays a big role, yes. So this is why I mentioned that with good conditions, the current can be 100 microamps. But if you are very far from the cell and you are in this power class 2, then it can be up to 10 times higher power consumption. So from 100 microamps, you get to 1 milliamp. And then the base current of Chester is not that significant because the transmission will take the majority, and the lifespan of the device will be maybe sometimes less than 1 year.
Yeah. What we can do if we can see that the consumption is too high, to power our devices just from one primary cell.
Yeah, so we have a solution for that. This is why we are developing these battery packs. We have now integrated this battery pack, which is new product. We call it Chester B1. It comes with this same looking enclosure, but it's just proportionally bigger. And inside you can install up to 8 C-cell size batteries or 6 D-cell size batteries. And with these D cells, bulk batteries, you get like 112 amp hours of juice for your applications, which is 12 times more than with this default battery. And we have customers who are demanding, right, these guaranteed operation times for 3 or 5 years. So even in the worst conditions, so that's one reason how to do that. Or simply there is a bigger requirement for more dense transmissions or acquisition from the sensors. So it makes a lot of sense. Sometimes customers are demanding solar power systems. So we are also creating a solution that will be very solid. But usually we try to understand the customers, why would they go for solar rather than installing these bulk battery packs, because it's easier for installation and it may be sometimes even more economical approach.
And could you mention our solar approach too? Because lately we've been working on some solution with the solar panels or photovoltaic panels.
Yeah, so we already have solution today. We have Chester Z, and as you know, Chester has a rechargeable LPWAN battery inside, the standard cell 18650, and this is, I would say, all right solution for some use cases. But the problem with this rechargeable LPWAN is the temperature span. So if you want to go to really harsh conditions, then you may want to use different battery. So lead acid, we found out, is the leading type of chemistry for such applications. And we are working on a product that will integrate the solar MPPT tracker and the lead acid battery. And we will only use DC-DC regulator in Chester to convert power from like 12 volts. And there will be external box with solar panel and this lead acid battery.
Thank you, Pavel. And sorry for our problems with audio. Guys are trying to fix it. But let's go to another question from Rastislav. Do you think GPRS or 2G can be replaced by LTE-M or narrowband IoT in discarded areas where there is only a weak signal, GSM signal? I have the feeling that operators focus only on the dense inhabited of the location.
So that's a very good question, and we cannot put guarantees for the operators. And there might be really some edge cases where operators, as you say, might be focusing temporarily on urban areas. So far, we have come only across one such situation. But what we are seeing mostly is that the carriers, once they invest into licensing of the LTE-M and NB-IoT technologies, they just switch it on completely nationwide. And I can tell you that definitely it is better in terms of coverage than GPRS or Edge. And we have tested that. We have proved that in one of our projects with Svenborg brakes. We were monitoring these industrial brakes. It was really a harsh environmental project in the Czech Republic, in a place where there was no GPRS signal. And our NB-IoT units have been, with Chester, have been performing already for several years very, very well. So this is like one use case that proved that actually NB-IoT has better penetration.
So theoretically, when operator will decide to switch on narrowband IoT, they will switch it on all their towers. So in this case, it should be better than GPRS because even like speaking about physics, this technology is much better than.
Of course, GPRS allows you to transmit more data. But speaking LTE-M, I would say technically it's better in every single aspect. You consume less power, you communicate over larger distances, you have better latency. So LTE-M definitely is a good replacement. But NB-IoT, as we said, it's still leading the edge in terms of coverage.
Okay, thank you. Another question from Louis Riccardi. I'm not clear if the satellite services require of a gateway to onboard the endpoint device, meaning to transfer information from the device to the internet. So the question is about, what is required. So we mentioned that we are working on special modules.
Yeah, so I will take this example with Astrocast, and you can search it up on the website. They have quite clear communication about how to start with satellite communication. You have to get the dev kit, and they are selling modules. So these are actually fairly simple to solder modules. The price range is, I will not tell exactly, but it's like lower tens of dollars. And you can get it. You have to connect antenna, and it has UART interface. So it's very straightforward for integration. What I have studied, you only send it just a packet of data, and it's fire and forget from your perspective. They cache the data, and they are calculating and synchronizing the path of the satellite on a low orbit. And when it's the appropriate time window, this opportunity, it will transmit the message, and the message will be delivered, for example, to this Azure IoT Hub, which is the integration connector.
Many people are waiting for these satellites modules.
I'm looking forward to that. Yeah,
like even Jose. Hi, Jose. So definitely, when these devices will be ready, we will have another webinar, and we will
just about this.
This, definitely. Okay, so let's go to questions. We received before the webinar, and they are very simple about what countries are covered by narrowband IoT and LTE-M. I will mention that you can go to gsma.com website, and there is one link which is it's a mobile IoT commercial launches, and you will see all countries and all operators, all carriers, and what state they are in. So if it's narrowband is already launched, or LTE-M, or both of these technologies. So this is one nice source of information. Of course, then you can ask other carriers, if they are already launched.
I want to say, be careful. Not always all these information are up to date. So if you are actually looking for a specific territory, we usually just Google up the territory in connection with NB-IoT and LTE-M networks, and often you will come across press releases of the carriers and telling you more information, and you can approach them and ask about the availability. Or just ask us, and we will help you to figure out, because we have connected.
This is another thing about the prices and contracts. So in some countries, it's really hard, to get good prices, and even us. And we have in these countries several hundreds of installations. And but speaking about our offer, for example, Vodafone Narrowband IoT and our cloud, the price is around $1 or €1 per month, and it includes all like connectivity, cloud services, cloud API, and our support. So this is something, it's hard, to achieve, when you will approach individually these carriers. So like Pavel said, don't hesitate to contact us, and we will tell you if this area is covered. And the same price is about these satellites modules. What they can expect.
It will, of course, it's a little bit more expensive comparing, if you are comparing the amount of transmitted data and the cost per that amount, it's much higher. On the other hand, even that area, we think that will be a competing market. It is already nice today for many applications that need to only do a basic telemetry, and we know the pricing. It's stated even on Astrocast that it can go to like $1 per device per month for a few messages a month. I don't know exactly. Maybe you know the conditions.
1 kilobyte.
For 1 kilobyte a month. So we will see how it develops. But it's something that's already a big shift, because there have been players in satellite segment, but they were more targeting these high volume, and it was very pricey. Sometimes paying hundreds of dollars for monthly connectivity, but this is now changing for IoT space.
Okay. Question about our new modules for Chester device, and the same, what type of SIM cards they can use, with this cellular technology. So probably let's start with the SIM cards.
Yeah, exactly. So speaking of the SIM card, when we deploy the Chester units to Vodafone networks, we always prefer delivering the SIM chip soldered directly on the board. It's just better in general, even though we haven't had yet any problems with nano SIM holder that we have also as the other option in Chester, because when we go to the US or to other territories, to other carriers, sometimes we need this flexibility of swapping SIM cards. So we do not do SIM chip for anybody else so far than Vodafone. But yeah, it's the nano SIM and SIM chip what we have as an option. Maybe in the future we will expand the family of SIM chips, but there has to be a decent volume for the project and territory.
Okay, and last question, new complementary modules or add-ons to Chester, what is in our pipeline, it's for our customers and our partners?
Absolutely, so we are always expanding the possibilities of our gateway. And one of the most exciting that we are soon introducing is Chester S1, which is targeting environmental monitoring applications. So the module will be optionally equipped with lux meter, temperature, humidity, and CO2. Also, there will be optional part this PIR detector. So we can detect human presence, do some people counting, and maybe the barometer. Yeah, I think barometer option is there as well, and the microphone
lux meter. Yeah.
So what we do for this Chester S1 variant, we do milling on the sides of the enclosure, so that there is possible airflow, especially for the CO2 measurements. This is essential. And yeah, it will be like integrated all-in-one environmental sensor that will be connected through a system connector via I2C to the main board. So the electronics of this sensor board will be sitting in the top cover, similar like Chester Z. Also, the other module that we are introducing actually together with this Chester S1 is expansion module Chester X10, which is a DC-DC converter with a wide span of voltages, but it has integrated this lithium polymer charge on it. So we will have the option to have rechargeable flat lithium polymer batteries somewhere sticked on a main board, and you will have the DC power input to recharge it and have it operational for several months. So this is actually quite related to this environmental monitoring, because this is for indoor. And in there, it is nice to have this rechargeable connector, and you don't need this lithium for very wide operating temperature range. So that's another. But we are adding some more, so definitely we will keep you posted.
It's perfect, and if you can, just like our video and subscribe to our channel, sign up for our newsletters, or just follow us on LinkedIn or Twitter. This is it. Thank you for watching this webinar. Have a wonderful summer. We'll see each other hopefully in August or September. And Pavel mentioned that we will talk about
Chester SDK,
which is open for our partners, but it's something you can jump into this new Zephyr RTOS world, and we will help you to be oriented in. Pavel, thank you.
Thank you all.
Again.
Thank you all. Have a nice day.
See you. Bye-bye.